Some people think that we're not alone in the universe and that right now we're being watched by intelligent beings. Let's face it, as one planet among billions in the universe, it's quite likely there's some truth that we're not alone. The question is, how is intelligent life going to make contact with us? Or maybe they already have. On Earth, we communicate using sound. We talk, we sing, we play musical instruments, or not, as the case may be. Sound is a pressure wave moving through the air. But as space has no air and is a vacuum, sound can't travel through it. It's more likely that if alien life wants to make contact with us, they'll use radio waves, microwaves, or some other part of the electromagnetic spectrum. All these forms of radiation can travel through space. The electromagnetic spectrum has a range of frequencies like sound, starting from high and moving all the way down to low frequencies. At the one end of the spectrum, there's the high frequencies like X-rays, and at the bottom end, low frequencies like radio waves.
The electromagnetic spectrum consists of high-frequency gamma rays and X-rays at one end. At lower frequencies, there are ultraviolet, visible light and infrared waves. At still lower frequencies, there are microwaves and radio waves. All these waves travel at the speed of light and can be described by their wavelength, or frequency. Frequency is measured in hertz. 1 hertz is 1 wave per second. 2 hertz is 2 waves per second. 4 hertz is 4 waves per second. 1,000,000 waves per second is called a megahertz. Wavelength and frequency are related. As the waves get shorter, the frequency increases. If the frequency is doubled, the wavelength is halved.
So, if intelligent life forms do exist, are they going to break into your favourite breakfast show on 98.8 megahertz FM? That's not going to happen because those kinds of radio waves are very short waves and occupy the VHF, or very high frequency part of the electromagnetic spectrum, which can't pass through the Earth's atmosphere. Now, if you want to pass through the Earth's atmosphere, you need even shorter waves. I'm talking ultra short waves and microwaves.
Lower frequency radio waves are reflected by charged particles in the upper atmosphere. Higher frequency radio waves, like UHF waves, are not reflected and carry on travelling through space.
It's as if there's a window in the Earth's atmosphere through which only certain radio waves can pass, those with a frequency between 300 megahertz and 3 million megahertz. 300 megahertz has a wavelength of 1 metre. 3 million megahertz has a wavelength about the thickness of one of my hairs.
Is this frequency in use, please?
Is this frequency occupied? Gold 0, Echo, Charlie, Papa, over.
That's the voice of the man I'm here to meet today, from the SETI League, the Search for Extraterrestrial Intelligence. And believe it or not, his HQ is in that house, in Stockton-on-Tees. Hello, Trevor.
Hello there, Jason.
Good to see you. Now, you're a member of the SETI League. Tell me, what's the SETI League all about?
Well, it stands for the Search for Extraterrestrial Intelligence.
What exactly are you searching for?
And we're searching for radio waves and electromagnetic signals from space.
I've got to ask you one question, Trevor. Do you believe in aliens?
But scientists believe that there are so many other planetary systems like our own that it would be inconceivable that there isn't life elsewhere.
And if there is, I bet you're the man to find it.
We'll certainly do our best.
Are you going to find it with a kit like this?
Well, that's where it's going to come from, I'm convinced of that.
Can I see this thing?
You most certainly can. Well, this is the parabolic dish.
Yeah.
And it's shaped as such that all the signal is catched in this catchment area, focused up into the feed-on,
yeah,
out through this. And because the signal's so weak, because of the vast distances that it's travelling,
yeah,
it would need an amplifier, and it's amplified through the signal and out into the radio room.
So how far into space is this looking?
Well, we're looking between 300 to 400 light years with this particular one.
The distance light or radio waves travel in a year is called a light year. In 1 light year, radio signals will have travelled 10 million kilometres. So in 300 light years, they will have travelled 3,000 million kilometres. Trevor has converted his spare room into a control room for his radio telescope. He's been monitoring the skies for signals from extraterrestrials 24 hours a day for the past 3 years.
Okay, so this is your SETI monitoring station. What exactly are you monitoring?
Oh, we're monitoring the microwave region,
Yeah.
as you can see here.
That's what all the numbers are ticking in front of us.
Yes, it is.
And what happens if you receive a signal that you think could be extraterrestrial?
The scanner would stop
Yeah.
at that certain frequency, and the signal would appear on the screen.
At which point you'd then sort of jump out of your chair, shout, "Oh my goodness," run over, and what would the next course of action be?
I'd want to take a picture of the actual signal and a recording of the sound.
I guess the big question is, have you ever received anything?
Well, I can show you one.
So this is an image of what you've
And
actually
that was the
received.
image of the signal that I received. It was found to be a military satellite.
Have there ever been any signals received that couldn't be explained away?
Yes, in 1977 there was a signal
Yeah.
which has been unexplained to this day.
Could this be the message we've all been waiting for? The 1s and 2s represent the background radiation which is bombarding the Earth all the time. The higher numbers are not background radiation and have never been explained, nor has this signal been detected since. Is this a message from an extraterrestrial life form?
When the scientist found it, he said to himself, "Wow," and he wrote "wow" in the border, and it's then become known as the wow signal.
Well, thanks very much, Trevor, and be sure to let me know if you hear anything.
Come back.
Thanks a lot.
Thank you, Faye.
Hey, Trevor. Trevor, come back. Don't forget about me, mate. Here. Trevor. Charming. Well, there's nothing on again. But if aliens from some distant planet were to tune in and try and watch our TV pictures, what would they see? Would they see me as I am now? Some interference? Or maybe a TV show from some distant time? Whatever, it's all to do with how we transmit our television pictures. If you want to know how television is transmitted, this is the place to be, the BT Tower, in the centre of London. All television broadcasters use it, be they cable, terrestrial or satellites. And I'm going to talk to a person who knows how it all works on the 29th floor. 29, please. Good grief! Look at this place! This is amazing. You must be Katie.
Yeah,
How you doing? How high are we now? We're too high, aren't we?
29 floors.
29 floors? Why do we need to be 29 floors up?
Well, we're transmitting using microwaves. Microwaves only go in straight lines. We don't want to be blocked by buildings or hills or anything.
Now, let me just get this straight. We're not talking about the microwave in my kitchen, are we?
No, microwaves in kitchens use very specific microwave frequency that agitates the water molecules. We've got different frequencies up here.
OK, so how does the signal, the television signal from the broadcasters, get to this tower?
Well, even before it leaves the broadcast studio, the TV picture has been converted into pulses of infrared light.
The television picture is made up of pixels. The brightness of each pixel is converted into a sequence of on and off pulses. This digital signal is carried by infrared radiation along optical fibres from the broadcaster to the BT tower. Inside the tower, a special machine converts the infrared pulses to microwaves. These are sent up hollow tubes to the appropriate microwave dish.
Technicians in the